Black holes. We're fascinated by their destructive power.
Black holes are dangerous. Black holes are hazards. Black holes are not friendly for their environments.
There's just no good end to anything that falls into a black hole.
Perhaps one of the most frightening objects in the universe.
But what exactly are these scary objects?
Black holes are created when you get enough matter in a small region of space.
This happens when a massive star dies and collapses in on itself. A supernova.
A black hole is the ultimate consequence of gravity.
Is an object that has so much mass crushed into such a small space that its escape velocity becomes greater than the speed of light.
They are a one-way street. You go in, nothing escapes, not even light.
But do black holes deserve their bad rap?
In some ways, I think we set up black holes to be more villains than they actually are.
Black holes suffer a bit of a PR problem. I think they're a lot more menacing in science fiction and popular media than they really are.
There are trillions of galaxies in the known universe, and most of them have a supermassive black hole at their center. These monsters are millions of times the mass of our sun. Their immense gravity can send stars flying.
They're instrumental in choreographing the dance of stars in their vicinity.
Supermassive black holes shoot out torrents of lethal radiation and violent cosmic winds, and gobble up anything that comes close. Now physicists are beginning to realize these cosmic giants may also have a creative side.
Most people think of black holes as being like giant vacuum cleaners in space, and basically everything falls into them. But that's not actually the case.
They're better thought of as the engines of cosmic change.
Although black holes are the end states of stars, they can actually influence the formation of stars as well, in a bunch of different ways.
A galaxy's job is to make stars. But uncontrolled star growth is not healthy. Too many stars can drain a galaxy's gas supply.
Black holes are very important. It appears that galaxy evolution is tied to black hole evolution. We don't know exactly how yet, but the marriage appears certain.
As gas falls toward the supermassive black hole, it becomes superheated, it liberates an enormous amount of energy, and that energy has to go somewhere.
As gas spirals towards the black hole, some of the material accelerates to near the speed of light. It blasts out from the accretion disk, creating chimneys of superheated gas that seem to connect to two of the largest structures in the galaxy, the Milky Way's Fermi bubbles.
A few years ago, we noticed that, in fact, there are these giant bubbles coming out of the very heart of the Milky Way galaxy. In each direction, there's a bubble 25,000 light years long.
But the gas-filled bubbles dwarf the chimneys. Scientists wonder if another more powerful force blew the bubbles.
So what could have created all of this superheated gas that actually blew these tremendously large bubbles?
Black holes in other galaxies might offer clues.
Black holes at the centers of galaxies go through different phases, so they can be either active or they can be calm. Sometimes black holes at the centers of galaxies go through an active phase. And when that happens, the black hole is actively feeding on material around it, which means it's growing, and it also gives off huge jets of radiation.
calm supermassive black holes release a trickle of hot gas. But when lots of material falls on them, they can shoot out jets up to millions of light years long.
At the current time, Sagittarius A star is what we call quiescent. It's quiet. There is some material swirling around it, but really not very much. But we don't think that's always been the case. The centers of galaxies are busy places. There are stars there, there's gas there, there's dust there, and sometimes these things fall into that black hole.
6 million years ago, Sagittarius A star may have had a feeding frenzy. Eating too much and blasting out the remains in huge jets.
Those jets plow through the galaxy initially at near the speed of light. And as they do so, they can wreak havoc or sculpt the evolution of the galaxy that they're propagating through.
Sagittarius A star's jets blasted gas out of the galaxy, creating the scars we see as the Fermi bubbles.
We don't really know how common supermassive black hole mergers were in the early universe, but we think they were more common than they are today because galaxies were closer together.
We've seen supermassive black holes on their way to merging, and we've seen ones that we think had gone through mergers, but we haven't caught one in the moment.
As supermassive black holes start merging, they spiral around each other, getting faster and faster the closer they get. But for them to finally merge together into a single black hole, they need to lose what astronomers call orbital energy.
We believe that supermassive black holes must merge. We know that galaxies merge, and so if the black holes didn't merge, we'd see lots of black holes floating around, and we don't. There's always one in the middle. So how do they merge?
In 2019, we found something that appears to solve the final parsec problem. A galaxy in the middle of a merger that contains not 2 supermassive black holes, but 3.
3 supermassive black holes. Now that's really cool. Sometimes you can have 3 galaxies that are merging together in a galaxy cluster. Then you have 3 supermassive black holes. At this point, it's virtually impossible for there to be a final parsec problem.
Here's how a 3rd black hole solves the final parsec problem. 2 of the black holes orbit closer and closer, ejecting stars to lose energy. Black hole number 3 joins the action. Its gravitational pull takes even more energy from the orbiting pair. Eventually, they lose enough orbital energy to collide.
That 3rd supermassive black hole is just what's needed to transfer energy away from the 2 merging black holes so that they can now merge into one single supermassive black hole.
Triple black hole events may explain how the earliest supermassive black holes grew to such enormous size.
We've suspected that 3 black holes may be necessary in order to get black holes to merge, but we've never had any evidence for it. But now this might provide a direct picture of 3 black holes caught in the act itself. If we have a picture of this happening now, then it certainly happened in the early universe and might explain how the biggest black holes got so big so quickly.